An understanding of Pythagoras' theorem is actually essential to understanding trigonometry with right-angled triangles. So we're just going to review Pythagoras' theorem quickly, even though we've seen it before, so that we understand where we can take it. Now, this is just one of many proofs for Pythagoras' theorem. So a quick run through of this to remind you what we're talking about might be helpful. I've drawn two squares here. They're identical size. You can tell they're identical because both of them have a side length of a plus b. Now, both of the squares also contain four of these right-angled triangles, and they are all the same size. They have height a and base b, and they've all got a right angle in the corner of them. So simply by rearranging where those four purple triangles sit in this picture, I'm able to show that if both squares are the exact same size around the edge, and both of them contain identical four purple triangles, then the space that's left, the white part, must actually be the same size in area. So how big is this side? Well, we've got a square. C times C equals C squared, so the area of that square is C squared. This is B times B, so the area of this white space is B squared. And down here we have A times A squared. So this is a nice little proof using areas to show that A squared plus B squared equals C squared. Now, how does this help us? Well, when we learn about Pythagoras, what we find is that if the triangle has a right angle, and it has to have a right angle for this to work, then if we know any two sides of a triangle, let's say we know these two, we can plug those in and we can figure out what the third side is. Now, how does that help us with trig? Well, the idea with trig is that if we know any two sides of a right angled triangle, we could also figure out the angles. And this is important because we actually don't need all three sides here to figure out everything there is to know about a particular right angled triangle. We only need two, because once you have that right angle, and once you have any two sides, whether it's these two, or perhaps these two, or perhaps you have the 5 here and you have this, you can always work out the other side. There's only one thing it could possibly be. Now, if you then take that idea into similar triangles, you'll see where I'm going with this. Let's take our 3, 4, 5 triangle and we'll label the angles on it. Let's just give this one one curvy line and this one can have two, so they're two different symbols. If I was to enlarge this triangle, or reduce it for that matter, I would create a similar triangle. Now, what I mean by similar, not exactly the same, but to be mathematically similar, it's a basic enlargement or reduction. So let's just say I doubled the size of this triangle, changed the 3 to 6, made the 4 into 8, and the 5 into 10. What I can deduce then is that because the sides are in the same ratio as this smaller triangle, the angles are actually identical. And that's a quality that you get with similar triangles. If the angles are the same, then the sides are in the same ratio. Or if the sides are in the same ratio, then the angles must be the same. And that's crucial to understanding trigonometry. Now, how many sides do we really need to be able to know that this is true? Do we need all three? Or would it be enough if we had this information to deduce that these two triangles are similar? This actually would be enough. There's only one thing this third side can be when it's got 3 and 4 and a right angle. So there's also only one thing that this side could be if we've got 6, 8 and a right angle. Now, moving into trig, what we're saying is, all right, if we know any two sides of a right angled triangle, we basically know 3. We could easily figure it out if we need to. So if we know those two sides, then we also know what angle that type of triangle might have. Now, when I say type of triangle, I mean all the triangles that are in a similar size ratio, have sides in the same ratio, would have those same angles. So if we want to figure out what one of the angles might be, when we're doing trigonometry, if we know any two sides, let's say we know two sides, we don't need to find the third side right now, but if somebody's asking us what one of the angles might be, and this must be in a right angled triangle, I should add, we can figure this out because every triangle that has these two sides in this ratio has that exact same angle there. And this is predictable. Across time and space, everywhere you go, every triangle, let's draw another one, every triangle that has a right angle and has its sides in this proportion, let's make this one be twice the size. it'll have that exact same angle there. So it's quite cool we're able to work out what angle goes with these, and that way we can use our calculator to figure out what it might be. At the same time, if we know an angle and we know one of the sides, then we can figure out any one of the other sides. And that's really the basis of how trig works and why it relates to Pythagoras' theorem and why two sides is enough to find any angle, given that you have a right angle, of course.